Hello and welcome. Today we'll talk about networking in cloud. We'll start with a quick review. So when we compare our models, we'll go with the OSI 7-layer model. We get a bit more nuance. So a quick review of that. Starting at the bottom at the physical is our obviously physical layer where you can touch, measure, and see. Layer 2, data link layer, is peer-to-peer connectivity. Layer 3 is IP addressing. Layer 4 is transport, which is TCP/UDP. Layer 5 is connection management and handshakes. Layer 6 is presentation. This is where encryption happens. And layer 7 is the application layer where your apps actually live. So to put it with some devices and concepts, the physical layer has your cables and wires. It also is where your NIC devices are. These are network interface cards. Moving up, layer 2, data link layer, is where your switches are. Remember, switches are like dumb routers. They just forward packets to the next hop. When you talk about an address at layer 2, it's usually your MAC address. So that's your media access control. So not PC or Apple. It's media access control that's assigned to each device. If you flip over a home router, you'll see this little barcode. That's the MAC address assigned. Layer 2 is also where you have frames for encapsulation. So in the network layer, layer 3, your router can read the inside of those frames and forward and move your packets to the right location. So they do this with IP addresses, which, if you remember our postal analogy, IP addresses are like the to and from listings on your envelope. Nobody opens your mail and reads it, but they know the right location to send it to. And if we hop on up to layer 6, that's where encryption happens, and layer 7 is your actual application. Remember, IPsec is a network layer, layer 3 thing. And then for those devices, again, a switch uses packet switching to just hop on to the next hub or hop. A router directs packets from a source to the destination, and it uses packet forwarding mechanisms. So switches only look at the link layer address, your MAC address, not your IP datagram, which is your IP address, and that's what routers do. Also, firewalls are devices that prevent certain types of communication based on network policy. And finally, network address translation, or NAT, converts your internal to external network addresses. Quick note, NAT is a function, not a device. So you can have a NAT firewall or NAT router. And finally, VLANs versus VPNs. VLANs are layer 2, VPNs are 1 through 3. So VPNs can ensure secure connections between LANs, VLANs, and clouds. So when we talk about a little bit higher layer networks, it's either VPNs or VPCs. VLANs are local cables and things. All right, let's put these all together. So when we talk about public versus private networks, we talk about IP addresses and how you can figure out which one's public versus private. A public address is globally routable. It's a unicast IP address that is publicly available. Because it's public, it's unique to that device, and it can be accessed and viewed by any other device on the internet. A private IP and a private IP address device is only routable and viewable through other devices in that network. If you have a device on a private network, it has to connect to the internet. You can use network address translation. So again, here your router is using NAT. So it translates from your internal to your external. So here's how this works. Again, NAT is network address translation. It allows your private IP network to connect with public IP. So your router can connect those two different networks using NAT to translate. So here in our example, our internal device is 192.168.1.1. Traffic goes to that router, which uses NAT to translate that to the public network, which is 10.0.0.0. So to use NAT, you need an external interface on the outside, an internal interface on the inside, and a set of rules for how to translate private to public. So in cloud, when we talk about NAT, both Azure and AWS have a concept for NAT gateway. So if you have a VM or instance in a private subnet in your cloud, you can connect it to the internet through a NAT gateway device. It's usually its own instance. You put the NAT in a public subnet, so your traffic goes from your private subnet over to your public subnet. Your NAT does the translating and then connects to the internet gateway and to the public internet, so no one can see your private subnet devices. So to kind of continue with this theme, the firewall prevents and filters certain types of communication based on network policy. There are two types, network layer and application layer. A network layer is also called a packet filterer. It applies filtering rules to either allow or block on a per port or IP address basis. Application layer firewalls, on the other hand, apply filtering rules to allow and block on a per process basis. So if you want to think about dumb versus smarter, application layer is a little bit smarter. So for example, a network layer, you can block TCP completely, but you might want to allow some TCP, but not all. So you'd use the application layer filtering on a per process basis. So you can specify which TCP processes are not allowed. You can also use NAT in a firewall, and in your NAT firewall, you can use this as a security function so that your internal network addresses are not publicly viewable, so you can kind of protect them with the added security. So again, another cloud example, both AWS and Azure have the concept of firewalls. These are security groups or network security groups. In both AWS and Azure, you can specify protocol, port, ICMP, and your source destination for each firewall. You can see in this AWS example, the type is a custom TCP rule. So it's a certain type of TCP protocol. I want to use port 8000, or down at the bottom, it's a port range, 1194 through 1197. And the source can be my IP address, or a custom IP address, or a range. And finally, just to put all this together in layers, when you talk about network ACLs in cloud, those are stateless packet filtering firewalls, and they're down at layer 3 network layer. Security groups are stateful. They're packet and port filtering, and those are between layer 4 and 5. So it's your transport and session layer. When we get to VNS3 firewalls, those are application layer firewalls. So it is possible to have all three, and it's usually recommended for our defense in depth. Next, we'll talk about VNS3 devices and how they all fit together.